All right, and finally we have Dr. Maureen Teyssier. She is Director of Data Science and Data Engineering at Reonomy, a data-as-a-service company, which is transforming the world's largest asset class. In previous roles, Dr. Teyssier drove technological and process advancements, which resulted in 500% year-over-year B2B contract growth at Enigma, a data-as-a-service company headquartered in New York City. She delivered smart technology, which anticipates human behavior and needs as a data scientist at Axon Vibe, created a smartwatch app recommender as a data science fellow in the Insight Data Science Fellows program, and studied galactic shapes resulting from the interplay between dark matter and stellar evolution as a postdoc associate at Rutgers. Her PhD is in computational astrophysics. She studied the evolution of galaxies by running cosmological simulations on supercomputers. Welcome, Dr. Teyssier.
I'm so happy to see all of you here today, and I want to thank you for having me here to speak on building and choosing the data science teams that succeed. There isn't a one-size-fits-all algorithm that you can use to create a success in a data science team. So what I'm going to do today is to create the contextual framework that you can use so that you can make more strategic decisions that will lead to greater success for your teams. So to do this, let's start from the largest context. So we'll look at the way that companies understand data science teams. So they think about what is at stake. Companies recognize that there is enormous potential across different industries and markets. They know that if they don't leverage data science and machine learning, other companies will, and potentially edge them out of business. They know that data science is a very high cost. There's a large investment in hiring. There's a large investment in paying for staff. There's a large investment in the compute resources. They're also very well aware that data science is high risk. They know that a large number of data science projects fail. So the largest stakeholders at companies don't have domain expertise in data science. And what this means is that they have a low level of understanding and low visibility into what is actually happening on the data science teams. The perception is changing over time, but to some degree, what happens on the data science teams is still a little bit magical. So this translates into a lack of understanding about the risk. They know that there's risk there, but they don't have the ability to understand what and where the risk is. But even so, there's willingness to step in a little bit blind because they understand that data scientists can make or break companies. They can change entire industries. So as someone that's building a team in this space that is very high risk and high reward and is in a complex space, you have to get right down to the meat of what you're doing. And what you're doing is you're ultimately building a product, right? And you will fail or succeed because of what is being built. So everything about the team that you're creating needs to be done with the intention of helping build exactly what is needed. The products that you build should drive the structure, both the structure of your team and the skills for your team. So even though it's tempting to follow the most standard engineering templates to fill in the data science need, front-end engineering team, back-end engineering team, DevOps team, data science team, that's not necessarily the best way to go about it, even though it happens very frequently. Data science is a different beast than engineering is. And companies are their own unique ecosystems. To thrive, data science has to find its ecological niche or niches within that system. Because companies don't really understand the practical limitations and the potential of data science the way that a subject matter expertise like you does understand it, the onus is upon you to understand the variety of ways that data science will thrive within the company. So when you're thinking about joining a team, when you are building a team, how do you understand whether the team is fitting within the niche in this company? So with enthusiasm, great curiosity, and even greater kindness, you interrogate every single human being that your project will affect. You talk to the customers, as Azia mentioned in her talk earlier today. You talk to them about what they're currently doing, what their pain points are, and how your work could affect their pain points. You talk to the C and V level people within the company to understand their vision and the way that they want the data science to look and the metrics that need to be met to mitigate risk. And then you also talk to the technical people on the different teams to understand what their pain points are, what's easy for them, where the risk is, the tech that they're interested in. And as you do this, you start to change culture or establish a culture within a company. So you become a data science advocate. Once you complete this process, hopefully you have a clear definition of success, and a minimum you have an idea of all of the different types of work, whether it's consistent or sporadic, that needs to be done to meet the company's needs. And hopefully you have some prioritization within that work. And to take it even further, potentially you have a dollar value assignment to the different components of the work. So once you do this, you're ready to move on to the next piece. And the next piece, I believe, is to look at how data moves through the company. Right? What is the volume of data through the company? Is there one stream? Are there multiple streams? Where does the data land? You want machine learning to be able to go to the correct pieces of the stream of data instead of trying to bring the stream to the data scientists. One way to kind of make this more concrete and clear is to use the data lake as a pinpoint, right? So if you have all of your data moving into one singular data lake, first of all, you're probably a startup and you're probably a new company. But having this type of infrastructure in place means that probably you can design your team in a couple of different ways. So potentially you can have a consolidated team of data scientists that are supported by engineering in the way that was described earlier today by Margaret. So there are what you see in this scenario is that it's it's a good environment for more junior data scientists. They can collaborate together. They grow together through that collaboration. If they have the support that they need from engineering, for example, by being able to just hook their algorithms onto a queue using a standardized hook, then it becomes very easy to complete their workflows. The things that you run into that become problems are that in this model, typically you have one person or a couple of people that are in management that become the bottleneck for the flow of information and ideas through the company. So the ideas that live in the company and the ideas that occur on the data science team have to pass through these few people. And that's a large burden for those people, and that becomes a point of risk. So not all startups look like this. For the past more than 2 years, I've been working at startups where our models are so early in the pipeline and so deeply embedded in the pipelines, they actually define the shape of these data lakes. So if you don't have a consolidated team, what is the other branch? What is the other option? The other option is a distributed team, and that's best for larger companies where you would otherwise have to wait for them to complete work so the data would be ready for you. The challenge there is that it's more of a management challenge, right? You have a team members that are living on different teams, building different products, and you have to collaborate with the other managers on the team who manage the front-end engineers, who manage your typical software engineers, and who potentially manage the data engineers. But what you see in these cross-functional teams is that the people that are mid-level data scientists or more senior data scientists, they're become very excited about this type of work. They're very excited about working with engineers because they have enough experience to understand that the engineering that they pick up from a really good engineer will supercharge their ability to do data science independently in the future. Okay, so we have two different views of what the teams could look like to support different scenarios for how data science flows through companies, for how data flows through companies. When you get right down to the bare bones, I think that there are really three main areas. So if you have established your guiding light, if you have established a good product fit with your interrogations that happened earlier, you don't need to necessarily have communication as one of these core skills. You don't need to have the collaboration with product as one of these core skills because you've already accomplished that. So you can focus on ML algorithms and statistics, so the talent for understanding what it is about the models that are causing them to behave in a different way and how to either change the model choice or change the model behavior by changing the algorithm. Data is a talent for understanding the underlying behavior of data and doing the data sleuthing that is, I think, so often neglected in companies and is a result of a lot of project failures. I've seen it create project failures. And I think that this, in particular, is something that's very difficult to teach. I know from my experience teaching and from conversations that I've had that if you're teaching how an algorithm works and you're teaching how to implement the algorithm, you don't need the additional complicating factor of trying to come up with a real-world data set that's going to muddy the waters. There's already enough subject material to cover in a semester. There's so much going on that adding this additional layer of this real-world scenario where the data is not quite appropriate, it's very noisy, you have to pull out signal, it's very time-consuming. It's very hard to teach that. So you generally only see it in people who have real-world experience, and especially in people who have to deal with public data. On the implementation side, this is more of an engineering aspect. You see that you get that from some types of PhDs. You see that from some like data science master's programs. But depending on the structure of the team and how data is moving through the company, your need is larger or smaller based on this. And so you need to be able to have that larger context to be able to gauge how important this implementation part is and what exactly that means. Right. So it's unlikely, probably, that you will be able to hire for that entire Venn diagram. So not everybody that you hire is going to cover all of these things, and that's fine. The team is going to have different strengths and weaknesses and talents, and together they need to be able to cover all of these areas to really supercharge the projects that they're building. And telling them that this is the context and this is the expectation and that they need to rely on each other really supercharges the team. It's very motivating. It's easier to recognize when you've made a mistake and accept that that's okay, because you know that you aren't supposed to be a genius in all three of these areas, right? Okay, so now at this point you have an idea of what the team needs to look like. You have an idea maybe of what the stack needs to look like from your conversations with engineers in the company. You have an understanding of what product needs to look like. You still, every time you create a new model, you still need to create a plan. So every time there's a new functionality, every time there's a new implementation of a machine learning algorithm, you need to create a spec. But it's beyond a spec, it's more of like a project plan. So there has to be a discussion and consensus around what is the data that needs to be made available. What are the features that we are potentially looking to create? What are the appropriate models? What are the metrics for success? Where is the risk? Is the risk in engineering? Is the risk in the volume of data and the latency of the response? Or is the risk in the algorithm and the metrics that you need to meet? So when you create a plan like this and you agree with the rest of the company on the plan, it gives them, it puts data science on equal footing with the other parts of the company. It puts it on equal footing with engineering, and it puts it on equal footing with product. And it gives them visibility into what's happening at different moments. So even though you don't see the kind of incremental building kind of burn down chart that you see in engineering, the company can still have confidence that you're actually accomplishing something substantial, right? And that kind of support is very invaluable. All right. So lastly, I'd like to talk a little bit about retention, because hiring is very difficult, understanding the project space is very difficult, but also keeping the people that are learning and growing within your teams is difficult. If you're joining a team, you need to look for someone that has a very clear vision, has a very clear idea of what they're doing and the value that they're providing for a company, and can provide you with a view with a very large horizon. So I mean, I interview people who are working at excellent companies, people who are working at companies like Google, who say, like, I have a great job and a great salary, and I live inside a black box. And data comes in and data goes out, and that's it. So you need to show them this horizon, say, look at this amazing thing that we're going to build. All of this will be ours, and you're going to build this part and this part and this part, and it is going to be amazing. And that is what, it drives engagement in the team. It gets people up in the morning. I think that it's also very critical to have a career growth map for data scientists. Data science is so new that a lot of the people that I work with don't understand how they can grow. They don't know what the next step is. They have some idea of titles and maybe not even some understanding of what they mean. But defining that really is both reassuring and I think inspiring. And then lastly, I think that when you work with your team, it's very important to take the time to step back, reflect on any successes that you have, share your successes, and just realize that this is an amazing moment in our history. The things that we can do now are just absolutely mind-boggling. And it's beautiful, and it's worth taking the minute to think about that and celebrate it. And that's it. Any questions?
Hi, very nice talk. I'm interested in kind of this thought that putting people with different skills together in the team to complement each other. I'm curious, are there any kind of qualities or specific characteristics you look for in applicants that they need to have regardless which specific skills they bring in, and kind of how do you best test for that?
If for cross-functional teams like you're describing, first of all, it's important to have someone that is actually interested in being part of the implementation. In smaller companies in particular, so there are actually very few companies where you can be a data scientist and do work and then just toss it over the wall and some engineers rewrite your work in C or some other language that is faster and more performant. I think kind of some willingness and enthusiasm around specifically like learning and learning new things and learning everything, right, is important.
Your level is very high enough that you're probably looking at, hey, how do I recruit different people? Mm-hmm. But for someone who is relatively junior, mm-hmm. when we are looking for teams, we usually look for the manager. What characteristic or what kind of things you think we should evaluate when we go to an interview?
Right.
Like they say, no, I'm not working for him or her, or
yeah,
definitely that's a person that you really admire, want to work for.
Yeah.
Do you have some advice on that?
Yeah, definitely. So I would suggest looking for people who talk about creating self-organizing teams, people who encourage the managers who encourage the people on their team to grow and do as much as they can. I believe that like Agile is made for engineering, but I think that if you have a project plan that I described, you can do distribution of work, and I think that the tenets of Agile are kind of self-organizing, that people grow really quickly, your responsibilities will likely grow very quickly. So I recommend joining Agile teams. I think that managers' clarity and communication, so if they can clearly define, like, this is a project I want you to work on, this is a project I want you to work on, this is a project I want you to work on, this is work that sometimes happens, you want to look for that, right? There will be some interviews that you go to where there will be a lack of specificity, and that's kind of a warning sign. And it's also a warning sign if they can't describe the value that is provided to the company. That kind of means that there's probably some poor communication within the departments, and that might translate into a lack of support. And it might mean that you're waiting around for data or you're waiting around for resources.
I will just ask Rachel. I may not have a framed question. I apologize, but I'm just trying to express my views and experiences.
Sure.
And trying to relate as a question. So I have worked in healthcare settings for several years. Both sides of the coins in healthcare, like doctor's office and also the insurance company.
Yeah.
And how they are two sides of the same coin. The data we collect, I collect data as my profession. So this is what I'm trying to say. The data scientists, I believe, work on the available data, what is there, but not what is not there. They don't assume, except that they try to replace and drop some columns and rows. I know that much. I don't work as a data scientist. But then, honest data versus like lack of data. Let's say I drink a glass of wine every night. I can't sleep. But then, do I really tell my doctor that I drink wine? I may say I never or rarely in parties, twice a year. Or maybe my friend or husband, whatever, who drinks 7 can of beers in one sitting.
Yep.
Will they present themselves
Mhm.
they don't. So it's really hard to get data. So one person who presents honest data
Mhm.
versus another who drinks 7 and then presents only 2 occasional, like twice a week versus every night. And then the lung cancer thing, like smoking and things like that. Uh, I already feel that being in a data scientist role, I may not be happy to see that data result that I get, because I know there are so many honest data versus
Mhm.
dishonest data.
Right.
So what do you think of creating more data scientist role by companies? Will this have a positive impact in future generation of people, us individual, to give honest data, like asking more questions to the company, to the providers, and then trying to dig into the data? Just like a mother who works in the kitchen from morning to evening and exposed to smoke
Mhm. Right.
working in a fire
Right.
versus a dad who
Right.
smokes 3 cigarettes per day,
Mhm.
whose lung is in more danger.
Right.
But are we collecting enough data? Will this encourage us?
No, you'll never have enough data. You'll never collect enough data. that's the easy answer to that. But look, because of your experience with data and because of your knowledge as a data scientist, you've identified a problem that doctors probably also have identified, but maybe you can identify the magnitude of the problem and a potential solution. So a potential solution would be to for example, I had a roommate who had very bad headaches, and so she had an app. Her doctor gave her an app, and on the app, it asked her every day, like, do you currently have a headache? Did you have a headache? How long was it? And potentially without a human there, like judging the person who is having 20 drinks a week, right? They could be more truthful, especially when they're being asked more granular. I think that potentially it's there's less incentive to lie when it's like, oh yeah, I only had 2 drinks today, and the next day it's like, well, I had 3 and it's fine because I hung, right? So I think that you have interesting feedback, and I think that there are potential solutions for problems like that. But definitely a lot of areas suffer from scarcity of data. Okay, cool. Thank you.